Alrighty, this is going to be FRQ number 4. We have the graph of the polar equation r is equal to 2 minus 4 sine of theta from 0 to 2 pi as shown in the figure. And for part A, we want to set up but do not evaluate a definite integral that represents the area of the region in the first quadrant bounded by the curve and the polar axis. So essentially, we want to find out this area right here. All right. So in order to do that, we need to figure out my zeros. So I'm going to have 0 is equal to 2 minus 4 sine of theta. That's going to give us negative 2 is equal to negative 4 sine of theta, which means that sine of theta needs to be equal to 1/2. Now thinking about that, so that is when theta is pi over 6 and 5 pi over 6, meaning that I have my intersection here being pi over 6. So if I'm going to set up my area and not evaluate it, I'm going to have 1/2 the integral from 0 to pi over 6. And then, of course, I have 2 minus 4 sine of theta square d theta, and then call it a day. Part B. A particle is traveling along this curve so that its position at time t is x of t, y of t, and we want to write expressions for dx dt and dy dt in terms of theta. Now here, remember that if I want t, I'm probably going to have r cosine of theta, and then we are going to have x is equal to 2 minus 4 sine of theta, cosine of theta. And we're going to take the derivative of this. So we are going to take the derivative of this with respect to t. And in order to do that, we are going to be using chain. So here we have first times the derivative of the second. And then since I take the derivative, I'm going to use chain. Okay. Plus second times the derivative of the first. And then since I take the derivative, I'm going to use chain. That gives me this lovely thing right there. Now just keep it unsimplified and call it a day. Don't do anything wonky there. It just tells you to write expressions for it so the AP graders can figure your mess out if needed. But make their lives easy on them and make your life easy on you by not simplifying it. We're going to do the same thing for r sine of theta. So instead of cosine, we have sine. So very similar process for dy dt here. So I have first times the derivative of the second plus second times the derivative of the first. Then, of course, don't forget about chain. And keep it like that and call it a day. So there is your dx dt, and there is your dy dt. All right, so let's look at part C. We want to write an equation in terms of x and y for the tangent line to the graph of the polar curve at the point where theta is equal to pi over 3. And we want to show the computations that lead to our answer. So here, whenever it says show the computations, it's going to ask us to actually figure out what we're plugging in. Yes, we could do this on the calculator, but remember it says show the computations. So here, I want to find the slope. So I want dy dx, and that is going to be at pi over 3. Remember that dy dx is going to be the same thing as dy d theta and dx d theta. So looking at that, I am going to have r cosine of theta plus r prime sine of theta over negative r sine of theta plus r prime cosine of theta. Okay, now once I do that, I am just going to call it a day because that is my computation. So I know that it's just going to be this right here, and I'm just going to plug in r prime cosine and sine of pi over 3. Okay, so Once I'm done with that, I need to figure out what x and y is at pi over 3. So, to do that, I have x right here already, and I have y right here already. So what I'm going to do here is just paste that down here, and then take that derivative at pi over 3. So whenever it says show the computation, it just means show your work in terms of what you are plugging into the calculator. So here we have x, we have y, we have our slope. And remember that this has to be the derivative at pi over 3. This right here has to be the derivative at pi over 3. So that's what I'm going to do now in my handy-dandy calculator. So going to my handy-dandy calculator, I want to make sure that my mode is in polar. And I want to type in 2 minus 4 sine of theta. And then I want to graph it from 0 to 2 pi. That's good. Graph. And that's this lovely thing right here, which is very similar to what we had in the figure. I'm going to do second calc. And I want to figure out dy dx at the value of pi over 3. Which gives us that. So at pi over 3, that's going to give us negative 9.19. 618. So that is going to be my derivative at pi over 3. All right, so that's done. We need to now figure out what my derivative of x is and what my, what my value of x is and what my value of y is. Sorry, since it's just in terms of x and y. We're not taking any derivatives here. But what we are going to do is plug in pi over 3 here and pi over 3 here and see what we get in terms of x and y. And that there actually has it right here in terms of x being negative 0.73205 and y being negative 1.26795. I'm not sure if the 84 actually does that for you, but this calculator does. And if the 84 doesn't do that for you, then of course you're just going to plug in pi over 3 and pi over 3 here for x and y. So when x of pi over 3 is equal to negative 0.732, and then y of pi over 3 is going to give us negative 1.267. We have our x and y values, and we have the slope, which means that we could find the tangent line being y plus 1.267 is equal to negative 9.916, x plus 0.732. And that is our tangent line at pi over 3. All right, the next video is going to be FRQ number 5, which is 2019 BC2.